So, hey everybody, today we are going to see a unit 2 arrays. So, let's jump into the introduction. The unit introduces a data structure called arrays. The simplest form of array is a one dimensional array that may be defined as a finite ordered set of homogeneous elements which is stored in contiguous memory locations. For example, an array may contain all integers or all characters or any other data type, but may not contain a mix of data types. The general form for declaring a single dimensional array is data underscore type array underscore name expression, where data underscore type represents data type of the array, that is integer, char, float, etc. Array underscore name is the name of array and expression which indicates the number of elements in the array. For example, consider the following C declaration. Int a 100. It declares an array of 100 integers. The amount of storage required to hold an array is directly related to its type and size. For a single dimensional array, the total size in bytes required for the array is computed as shown below. Memory required in bytes is equal to size of data type x length of array. The first array index value is referred to as its lower bound, and in C it is always 0, and the maximum index value is called its upper bound. The number of elements in the array called its range is given by upper bound, lower bound. We store values in the arrays during program execution. Let us now see the process of initializing an array while declaring it. Int a4 is equal to 34, 60, 93, 2. Int b is equal to 2, 3, 4, 5. Float c is equal to -4, 6, 81, 60. We conclude the following facts from these examples. If the array is initialized at the time of declaration, then the dimension of the array is optional. Till the array elements are not given any specific values, they contain garbage values. Objectives. After going through this unit, you will be able to use arrays as a proper data structure in programs. Know the advantages and disadvantages of arrays. Use multidimensional arrays and know the representation of arrays in memory. Arrays and pointers. C compiler does not check the bounds of arrays. It is your job to do the necessary work for checking boundaries whether needed. One of the most common arrays is a string, which is simply an array of characters terminated by a null character. The value of the null character is 0. A string constant is a one-dimensional array of characters terminated by a null character \0. For example, consider the following char message: examp le \o. Also consider the following string, which is stored in an array sentence \n. Figure 2.1 shows the way a character array is stored in memory. Each character in the array occupies 1 byte of memory, and the last character is always \0. Note that \0 and 0 are not the same. The elements of the characters array are stored in contiguous memory locations S, E, N, T, E, and C. E backslash and backslash 0. C concedes the fact that the user would use strings very often and hence provides a shortcut for initialization of strings. For example, the string used above can also be initialized as char name is equal to sentence backslash n. Note that in this declaration, it will be backslash o or backslash 0. I am calling it backslash o is not necessary. C inserts the null character automatically. It's backslash 0 only. Multidimensional arrays are defined in the same manner as one-dimensional arrays, except that a separate pair of square brackets is required for each subscript. Thus, a two-dimensional array will require two pairs of square brackets. A three-dimensional array will require three pairs of square brackets, and so on. The format of declaration of a multidimensional array in C is given below. Data underscore type, array underscore name, expression 1, expression 2, expression n, where data underscore type is the type of array such as int, char, etc. Array underscore name is the name of array, and expression 1, expression 2, expression n are positive valued integer expressions. The schematic of a two-dimensional array of size 3 into 5 is shown in figure 2.2, row 0, row 1, row 3. So here you can see the schematic of a two-dimensional array. In the case of a two-dimensional array, the following formula yields the number of bytes of memory needed to hold it. Bytes is equal to size of first index into size of second index into size of base type. The pointers in arrays are closely related. As you know, an array name without an index is a pointer to the first element in the array. Consider the following array: char p10. P and p0 are identical because the address of the first element of an array is the same as the address of the array. So an array name without an index generates a pointer. Conversely, a pointer can be indexed as if it were declared to be an array. For example, consider the following program fragment: int into x 8 10 x is equal to a, x5 is equal to 100 into x plus 15 is equal to 100. Both assignment statements place the value 100 in the sixth element of a. Furthermore, the 0, 4 element of a two-dimensional array may be referenced in the following two ways: either by array indexing a04 or by the pointer into int into a plus 4. In general, for any two-dimensional array, ajk is equivalent to base into base type into a plus j into row length into k. Sparse matrices. Matrices with good number of zero entries are called sparse matrices. Consider the following matrices of figure 2.3. So here you can see a triangular matrix and tridiagonal matrix. A triangular matrix is a square matrix in which all the elements either above or below the main diagonal are 0. Triangular matrices are sparse matrices. A tridiagonal matrix is a square matrix in which all the elements except for the main diagonals on the immediate upper and lower side are zeros. Tridiagonal matrices are also sparse matrices. Let us consider a sparse matrix from storage point of view. Suppose that the entire sparse matrix is stored, then a considerable amount of memory which stores the matrix consists of zeros. This is nothing but wastage of memory. In real life applications such as wastage may count to megabytes, so an efficient method of storing sparse matrices has to be looked into. So here you can see figure 2.4 shows a sparse matrix of order 7 into 6. 2.4 representation of a sparse matrix of order 7 into 6. A common way of representing non-zero elements of a sparse matrix is the three-tuple form. The first row of sparse matrix always specifies the number of rows, number of columns, and number of non-zero elements in the matrix. Number 7 represents the total number of rows, sparse matrix. Similarly, the number 6 represents the total number of columns in the matrix. The number 8 represents the total number of non-zero elements in the matrix. Each non-zero element is stored from the second row with the first and second elements of the row, indicating the row number and column number, respectively, in which the element is present in the original matrix. The third element in this row stores the actual value of the non-zero element. For example, the three-tuple representation of the matrix of figure 2.4 is shown in figure 2.5. Figure 2.5 three-tuple representation, figure 2.4. The following program 1.1 accepts a matrix as input, which is sparse, and prints the corresponding three-tuple representations. So here you can see program 1.1. The program accepts a matrix as input and prints the three-tuple representation of it. So here you can see the program. Okay, and yeah, you can see the output also here. Okay, you can just once try in and write the program in your IDE and check the output. Now let's see, the program initially prompted for the order of the input matrix with a warning that the order should not be greater than 5 into 5. After accepting the order, it prompts for the elements of the matrix. After accepting the matrix, it checks each element of the matrix for a non-zero. If the element is non-zero, then it prints the row number and column number of that element along with its value. So here we come till check your progress 1, and in next lecture we will start with the polynomials. So thank you for listening and keep exploring.